It is Tuesday, August 18th, and today we're going to take our unit circle and use it to calculate exact values of expressions that have trig ratios in them. Before we get to that, we're going to talk about how you get the rest of this unit circle filled in. Okay, so if we take a look at one of the things that we discussed yesterday was when you are finding the cosine of the sine of some value t, we wrap that t around the circle. So let's say I wrapped it around the edge of the circle and it reached pi over 6. When I calculate the sine value, what I'm really finding, it's the same thing as taking a ruler and measuring the length of that line segment. That's what sine is. Okay? When I do the cosine of some number t, now I'm finding the length of the segment that runs along the x-axis that takes me to that point. So the sine is the y-coordinate, and the cosine was the x-coordinate. Okay, attached to your classroom is this GeoGebra applet that gives you all the exact values that are on the unit circle. And by moving this green dot around, I can get all the different values any place I want to go on the unit circle. So we're going to start with the quadrantal angles. Those are the angles that are on the axes. So the angle that is 0, all right, its sine and cosine, its sine and cosine was 0 for its sine and 1 for its cosine. Now if I go all the way to the other side here, all that changes is the sine on the x-coordinate. It becomes -1, 0. Alright, so when I'm at this point right here, I know that my sine is at 0 radians. Okay, my sine, which is the y-coordinate, that's equal to 0, and my cosine at 0 radians is equal to 1. So what we have over here is a chart that you're going to be filling in as we work our way around the circle. Okay, so I just did at 0 radians, which is the same as 0 degrees, and our sine was 0, and our cosine was 1. Now the tangent, remember, is y over x, so the tangent would be 0 over 1, which is just 0. The cotangent is when you take the tangent and you flip it. Well, if you flip 0, it becomes 1 over 0, which is impossible. That's why the cotangent is undefined. The secant is I take the cosine and I flip it over. So if the cosine was 1, then I flip 1, it's still 1. And then the sine was 0 over 1, and when I flip it, I get 1 over 0, which is undefined. So there's your 6 values at 0 degrees. Now when we go to 90 degrees, our coordinate becomes 0, 1. Watch that one more time. So we just did this one. Okay, now we're at the other axis, the y-axis, and the cosine is now 0. So the cosine at pi over 2, or 90 degrees, is 0, and the sine is 1. Okay, now we can calculate our other values. So this is at 90 degrees. Okay, our sine was 1, our cosine is 0. Right, tangent is y over x. So when you do the tangent here, you get 1 over 0, which is undefined. When you flip that, you get 0 over 1, which is 0. Okay? The secant is the y value flipped over. Excuse me, the x value flipped over. Well, the x was 0, so when I take 0 over 1 and I flip it, I get 1 over 0, which is impossible. So that's undefined. And then when I flip sine, which was 1, it stays 1. Okay, now when we go to the third, or the 180 degrees, and whoops, looks like I skipped one here. I meant to stop right here, and looks like I didn't. Okay, this has the coordinates -1, 0. So that's my cosine, and that's my sine. Okay, so at 180 degrees, which is pi, the y coordinate's 0, the x coordinate's -1. And then my other values. So anytime you see an undefined on here, what that means is that there's a 0 on the in the denominator somewhere. That's what all of these mean. Because if you went 1 divided by 0 on your calculator, it would say error. It's okay to have 0 in the numerator, but you can't have it in the denominator. So any of those undefineds, that means 0 was in the denominator. All right, then now we go to 3 pi over 2, which was 270 degrees, and my cos is 0, and my sine is -1. So I filled that in on this chart here. Okay, cosine, the x coordinate, 0, y coordinate -1. Okay, y over x, this would be -1 over 0, undefined. This would be 0 over -1, which is okay. Okay, 1 over the x, that would be 1 over 0, no good. And when I flip -1, it stays -1. Okay, and now we're back at the beginning. Okay, so the 360 and the 0, you'll notice, are the exact same values because we're at the same place. So that's your, now you have all 6 values at each quadrant. Okay, when you land on the axis at each quadrant. Okay, the next increment on here is your 45-degree angles. So at 45 degrees yesterday, we came up with the x and the y coordinates being √2, √2. Now the way that you get the remaining numbers on the unit circle is all you're doing is taking that point and flipping it over the different axes. So if I took this point and I flipped it over the y-axis, all that's going to change is the signs on the values. So now it's -√2 over 2. Excuse me. Okay. Now, if I go back to my original, and instead of flipping it over the y-axis, I flip it over this line. So you had all these lines drawn on our unit circle. So those are the lines that you're flipping it over. This was the first one. Now we're going to take it and we're going to just trace that line, and it takes us right over here. So you can see on that, the values are the same. The only thing that changes is the signs. In the third quadrant, both of these are negative. Then I go back to my first quadrant again, and I flip it over the x-axis. Excuse me. And when I do that, the coordinates are still the same. The only thing that changes is the y is now negative. So when we're dealing with quadrants, plus plus, minus plus, minus minus, and plus minus. But the values stay the same. All you have to do is change the signs. Alright, so when we're dealing with pi over, or root 2 over 2's, okay, here's our different values. So I just did all the work just to kind of speed it up a little bit. Okay, remember your sine is your y, your cosine is your x. This is y over x. So some of these you end up with radicals in the denominator, like when you flip the sign. So when I flip the sign, I end up with a radical. So I had to rationalize it. And that would have came out to be root 2. When I had root 2 over root 2 for tangent, these are both the same, so when it simplifies, it becomes 1. Alright, so here were the values in the first quadrant. Okay, at pi over 4 degrees. Okay, and then if I go to the next quadrant, right there, the next instant of that is at 135 degrees. And if you notice, in this is quadrant 2, the y is positive, the x is negative. So tangent is going to be negative, cotangent is going to be negative, secant is going to be negative, and cosecant is positive. So this is quadrant 1, which are plus, plus. This is quadrant 2, which is a minus on the x and a plus on the y. Now we're in quadrant 3 at 5 pi over 4. And in quadrant 3, you got negative, negative. So the x and the y's are negative. But when you divide a negative by a negative, you get positive tangent and cotangents. And then the last instance is in the fourth quadrant. And we flip it over that direction. And in the fourth quadrant, the x coordinate is positive and the y coordinate is negative. Okay, so that's how you would fill in all the pi over 4's. So on this animation here, there's the first quadrant at pi over 4. I flip it over the y. All that changes is the sign on the x coordinate. Okay. When I go back to the original and I flip it over the origin, both signs change. And when I go back to the original and I flip it over the x, axes, just the y coordinate changes. Okay, our next increment on here is 30-degree angles, or pi over 3. So the pattern's the same. Once you know the first quadrant, guys, you can fill in the entire unit circle. Because when you flip it over to here, all that changes is the x coordinate. It goes to its negative. When you flip it to go down here, they both change to their to negatives. And then when I flip it, this direction right there, then all that changes is the y coordinate. So just by knowing the first quadrant, you can find all of them. So for this section, here are your different values. This is in the first quadrant. then here are the work on how when you end up with radicals in the denominator, what you got to do. Okay, we have to rationalize. So first quadrant here at pi over 6, this red one, this is quadrant 1, both the y and the x are positive. Okay, 5 pi over 6 was it in quadrant 2, negative positive. 7 pi over 6 is quadrant 3. Which is negative, negative. And then 11 pi over 6 is quadrant 4, which is positive, negative. And then these are your different values. So your sine, your cosine, okay, the y over the x, and then these values flipped. When I flip cosecant, I get secant, or cosine, and when I flip sine, I get cosecant. And the work for all of that is right above us. Okay, and then finally, the last one is your pi over 3s. That's 60 degrees. So now all that's changed is my x and my y have switched values. So now my cosine is 1/2 and my sine is root 3 over 2. Flip it over here, all that changes is the sign on the x coordinate. Flip it along the diagonal, both signs change to their opposite. They both become negative. Go back, flip it over the x-axis, and only the y changes. Okay. So then here's the work for getting the 6 ratios using this y coordinate and this x coordinate. And then that allows us to fill in the final column on this chart, which is the pi over 3 column. Okay. My y coordinate, my x coordinate, y divided by x is root 3. Flip root 3 and rationalize. Flip the x coordinate and flip the y coordinate and rationalize. Get these values. Okay, now I put this chart on the back of your unit circle that I put on a Google slide so that you'll have this to be able to use. Alright, now what you're going to do is use this chart to find the exact value of a trig expression. So trig expression is just, well, you're looking at them right now. Sine of 30, cosine 45. So all I do is just go take those values off of this chart and end up doing the arithmetic. Okay, so sine of 30, there's sine, that's 1/2, and cosine of 45 is root 2 over 2. So here I'm going to have 1/2 minus root 2 over 2. Well, remember, folks, you can't subtract fractions unless the denominators are the same, which in this case they are. So I can rewrite that as 1 minus root 2 divided by 2. And you leave it like this. That is what makes it the exact answer. You're not typing it into your calculator. Okay, sine at 90 degrees. So I go to 90. My sine is 1, and then I add the tangent at 45 degrees. Tangent at 45 is 1, so that's equal to 2. Okay, number 3. Cosecant at pi over 2. Okay. So I go to pi over 2, and I go down to the cosecant column. That's equal to 1. Okay, the cotangent at pi over 2, that's equal to 0. So 1 plus 0, 1. Okay, number 4. The tangent at 45 degrees, so tangent at 45, there's 45, tangent is 1. The cosine at 30 degrees, so I go to 30, cosine is root 3 over 2. Alright, now in order to add these, you've got to get a common denominator. So my common denominator is going to be a 2. So in order to turn this into a 2, I've got to multiply top and the bottom by 2. And the top becomes 2 times 1. And there's my exact value. Alright, number 5. 5 times the cosine at 90. Okay, so cosine at 90, there's cosine 90, that's 0. So this is just 5 times 0 minus 8 times 270. Well, 270 degrees is 3 pi over 2 right here. And I am looking for the sine. So sine right there, that's -1. So this would be 0 plus 8, which is 8. Okay, next one. 2 times the secant at pi over 4. So I go to pi over 4. Secant, that's root 2. Plus 4 times the cotangent at pi over 3. Pi over 3, cotangent, root 3 over 3. Alright, so we're going to simplify this. This is 2 root 2 over 1. And this is 4 root 3 over 3. So my least common denominator is 3. So I got to multiply top and bottom of this by 3. And I get 6 root 2 plus 4 root 3. And that's as far as you can go on this. Okay, you cannot combine the numerator because they're not like terms. They would both have to be root 2's or they would both have to be root 3's in order for me to add the 6 and the 4. Alright, sine 2 sine pi over 4. So sine at pi over 4 is going to be root 2 over 2. Pi over 4 right there. Plus, and then the tangent at pi over 4 is 1. So these 2's cancel, and I end up with the square root of 2 plus 3. And I can't add those because they're not like terms. Alrighty, last one. The secant of 30 times the cotangent of 45. So go to 30 degrees. Secant is 2 root 3 over 3. 2 root 3 over 3. And the cotangent at 45 is going to be cotangent 45, 1. So that's equal to 2 root 3 over 3. And that takes care of Tuesday, August 18th. You have Math Excel, I believe it's number 8. which is just like these 8 problems here. So have a good one, and I'll see you next time. Bye-bye.